Hello, this is Lab 5, Choose Your Own Adventure. I chose to model and compare the motion of two falling objects with the same mass but different shapes. It is commonly known that objects with the same mass should fall at the same speed. Even objects with different masses will fall at the same speed. Except, however, when you account for drag force. I found that the different shapes will have different drag forces, which will give them different net forces, and finally, different final velocities. To show this, I first wanted to model what a 1 gram falling object would look like in Python. I first set my initial conditions, the mass being 1 gram, the velocity being 0 because it's starting from rest. Then I made the calculation loop. I started with the fundamental principle, Newton's second law of motion, which states that the final velocity is equal to the initial velocity plus the net force divided by the mass times the change in time. For this part, I just set the net force equal to the force of gravity, which is shown here, and that will update the final velocity, which will then update the ball's position. This is the result that our Python code gives us. To compare, I analyzed the motion of a 1 gram cotton ball and a 1 gram piece of gum in Tracker. I used a piece of paper as my calibration and set my axes so that the negative y direction was the direction that the object fell. These are the results that I obtained from that. As you can see, they have the same mass, but they fell at different speeds. Now, let's see how our model compares. The model is almost exactly the same as the gum, which means that the gum had minimal drag force acting on it. The cotton ball's position, however, is over-predicted by the model. This means that the model says it should be falling faster. The reason for this is because the model does not include drag force. We account for drag by using the equation shown here. The constant b is found by trial and error trying to get the same final position. Below is how we enter this equation into Python. The place that we account for this is in the net force. We add the force of drag to the force of gravity to get our total net force. As you can see, the model with drag is much closer to our observed cotton ball. It is closer at the end and at the beginning, and less so in the middle because of the way that we found B. In conclusion, we see that it is not an object's mass that affects the speed in which it will fall, but the drag force that is acting on it. The drag force will be different from object to object depending on multiple things, the object's shape being one of them. This is why, even though the gum and the cotton ball both had a mass of 1 gram, they fell at different speeds.